Welcome to Unit 5, MathMyers. We did Unit 5, Section 5.1 in class, so I'll do a quick review of mid-segments in triangles. Now, the word mid-segment is broken up into two words, middle segment. Here is the middle segment. Now, when we talked about the middle segment, we talked about it in reference to the side that is parallel. Here is the side that is parallel. There's a relationship between these two. One is larger and one is smaller. Clearly, you can see that the third side, I call it the third side because I want to reference that this would be one side, this would be the second side, so I call that side the third side. It's the only side not connected to the mid-segment. We talked in class that this mid-segment reaches from here to here, and then we would need another one to go here. What does that mean? That means that we need two mid-segments just to equal the third side. So to be able to set this up as an equation, we would write 2x is equal to 18, divide by 2, and x is equal to 9. So if I erase this, you will be able to see that the mid-segment is 9, yet the third side is twice that, which is 18. Okay? Let's look at the second example here. We have a mid-segment. Which one is the mid-segment? Which one is the third side? Well, they should be parallel, so I want to identify my mid-segment all the time. And I want to identify the third side. And when I identify the mid-segment, I go back and grab it up with parentheses and put a 2 in front of it because I need two mid-segments just to equal one of that third side. So 2 times 5x is 10x, and 10x is equal to 70, and x is equal to 7. It said to find the value of x, so I'm done. Okay, this third one is for you to try. You can pause the video and try it, and then when you're ready, push play, and you'll see if you got the answer correct. There you go. How did you do? You always want to plug it back in just to see if it makes sense. So if I plug this back in for the mid-segment, I will write 3 times 14, and 3 times 14. How much is 3 times 14? It's 42. Is 42 half of 84? Yes. So my answer is correct and it makes sense. My next review question is this one. The mid-segment connects the middle of one side to the middle of the other side, and then I need to find out which side is parallel. Here it is. Those two are parallel. I always grab my mid-segment and multiply it by 2. The setup here, since this is an expression, is 2 times the quantity. X minus 1 is equal to 45. Don't forget to distribute. 2 times x is 2x, and 2 times negative 1 is negative 2. And this is equal to 45. I add 2 to both sides, and I get 2x is equal to 47. And then I divide by 2 and divide by 2. And x is equal to 23.5. Definitely, I encourage you to go back and plug it in just to see if your answer is reasonable. This one, I encourage you to try it on your own. Just pause the video, do it, see what your answer is, and check your work. Okay, here we go. We definitely multiplied the mid-segment by 2, did the appropriate work, and got x is equal to 11. Another thing that we worked on with section 5.1 is naming the segment that is parallel. It doesn't say anything else about an angle. It says the segment. So what I want to do is I want to look at number 14, and number 14 says, hey, where is segment AB and who's parallel to segment AB? So I'm going to go over here and I am going to highlight segment AB. Clearly I can see that segment AB is parallel to segment FE. So I'll write parallel to segment FE. So what you want to do with these problems is you want to identify the segment and then find the segment that it is parallel to. Okay? Let's try one more. I think I'm going to do, let's do CA. CA. Let me identify CA with a green marker. Here is CA. What is CA? Parallel to, and that would be EG. It is parallel to segment EG. So what do we know about these mid-segments? We know that if we have a mid-segment, that we definitely are going to see parallel sides. And we're definitely going to see a relationship between the mid-segment and the third side, and it's going to be twice the mid-segment equals, let me write it down here, the long side. All right, so we're going to roll right into 5.2. 5.2 is perpendicular and angle bisectors. I'm going to go ahead and let you copy down some of the theorems, and we will definitely make more sense in them in class. But I want you to key in on important words like perpendicular bisector in red. Perpendicular bisector. I want you to look at this word that's equidistant. What does that mean? It looks like it's made up of two words, and it is, equal and distant. So we're going to see congruent segments come out of that. So basically in this, folks, when I see a segment and a line, I'm going to connect to this point P on both sides, and oh, voila, have congruent triangles. I get you to copy down this theorem, which is the converse. We know the converse. We talk about converse, CO, changing the order. So, folks, if I start out with PA being congruent to PB, if I take a line and go down here, guess what? I've just created a perpendicular bisector. I have hypotenuse in the leg. So the triangles are going to definitely be congruent. So if A to this point is 6, then from here to here is definitely also 6. I'm going to show you more the application of these. Here's another theorem of postulate. I need you to pause the video and make sure you write these down. Key in on keywords. Point on a bisector. Folks, if we see a bisector, we know bisector is congruent. Pay attention to that. And we'll do some application problems that'll make these theorems and postulates come alive. You want to pause and make sure you get these in your notes. All right, in this unit, we're going to see some key vocabulary words. Perpendicular bisector is going to be one of our key vocabulary words. When you think about perpendicular, folks, what comes to mind? 90 degrees. Okay? So in 90 degrees, we're talking about angles. So here we are. These are 90-degree angles. But now we have this word bisector. Not only do we get perpendicular 90-degree angles, we get congruent segments as well. So this is 4, this is 4. So we get the double whammy with the perpendicular bisector. We get something about an angle, and we definitely get something about the segment. Okay? The next big word is going to be angle bisector. Let's think about that angle. So let me give you a picture of an angle. And now that I need a bisector. I know bisector is congruent parts. I do know that. So what I want to do with this is I want to create an angle bisector. I am going to split this angle down the middle. I'm going to put an arc, one arc, and one arc. What does that represent? It represents that those angles are congruent. So if this angle is 30 degrees, how much is this angle? Oh, you're right. It is also 30 degrees. So anytime you see angle bisector, we must see the notation with the arcs in order to realize they are congruent. What about this word equidistant? Equidistant is when a point is the same distance from a line. So what does that mean? It means that we're going to have congruent segments. We're definitely going to have congruent segments. Okay, folks, this is very key, and we talked about this in our last unit a lot. It says congruent triangles have congruent parts. Well, if the triangles are congruent, then what? The parts are congruent. We're going to reference this most of the time instead of saying all of this. We're going to say corresponding parts of congruent triangles are congruent. So what we're going to do is we're going to give it a code name, and the code name is CPCTC. All right, let's put this in action. Folks, here we have, look at this, congruent angles. So this is an angle bisector. Okay. Shared side. So what I'm seeing is that the triangles are congruent because of angle side. So if the triangles are congruent, the parts are congruent. So JK is congruent to JM. By substitution, I can say x plus 5 is equal to 2x minus 7. All right. Wrapping up the math and subtracting x on both sides and adding 7. We come up with x is equal to 12. The problem is that only answer one of the questions, which is x. So x is equal to 12. We got to figure out what JK is. If x is 12, we're going to replace x with 12. 12 plus 5 is 17. So JK is 17. Well, if JK is congruent to JM, then what is JM? JM is 17. Use the figure to right for exercises 12 through 15. According to the diagram, how far is L from HK? All right, how far is L from HK? Well, here's L. Here is HK. I could clearly see right here that that would be, what, 27. If that's the case, how far do you think it's going to be from LF? It's definitely going to be the closest distance. It's going to be 27 units from this segment and definitely 27 units from the other one. Okay. How is HL related to this angle? Well, when I look at HL here, how is it related to angle KHL? Well, I can clearly see that these triangles are congruent because I hypotenuse the leg. And if the triangles are congruent, then the parts are congruent. So that would make HL an angle bisector. All right, find the value of y. If the triangles are congruent, the parts are congruent. So we're going to set 6y equal to 4y plus 18. And when we solve for it, we get y is equal to 9. Okay? All righty. This is going to wrap up this segment. Determine whether A must be determine whether A must be on the bisector of TXR. Is A on the bisector? Well, here is TXR right here. I'm going to trace that out. Now, here's A. This way is 9 and this way is 8. Well, according to the theorem you wrote down, if it's going to be an angle bisector, it must be equidistant. Is 8 congruent to 9? No, it's not. Is A on the bisector? No, it is not. Let's take a look at this one here. Is A on the bisector? Well, guess what? These markings say they are congruent. And so, yes, it is.